So we did electrolysis. Ab thoda sa na what we're going to do is कि we will talk about uh, so we kind of done. ठीक है, तो Faraday constant कर लेते हैं. We're going to do Faraday constant, which is so Faraday constant is about calculating the the mole calculations related to electrochemistry. ठीक है. So for example, one electron has a charge of कितना coulombs होता था? That was 1.6 times 10 power minus 19 coulombs, right? So if you have 1 mole of electrons, so 1 mole of electron means that you have 6.02 times 10 to the power 23 electrons, right? And if each one of them has a charge of 1.6 times 10 power minus 19 coulombs, right? So in total, 1 mole of electrons is going. If you do the math, it's going to be 1 mole of electrons will have a charge of. In total, it's going to come out to be 96,500 coulombs. Okay. Fatma, is this clear? Okay. One electron has
Yes.
a charge of 1.6 times 10 power minus 19 coulombs. 1 mole of electrons will have a charge of. उसी को 1 mole को multiply कर लो 1.6 times 10 power minus 19 and you get 96,500 coulombs. So Faraday constant is basically nothing but this fact. Or इसको ना they often write it as the Faraday constant being is equal to F is equal to L times E. Yani 96,500 coulombs. L is the Avogadro's constant. That's 6.02 times 10 power 23. And E is 1.6 times 10 power minus 19 coulombs, right? So that's your Faraday constant, right? So F is equal to LE, right? So now, how do we use this Faraday constant? Faraday constant, that's used to convert between. So Faraday constant, that is used for this conversion. It's moles to charge conversion. So 1 mole of electrons has a charge of 96,500 coulombs. So you can use ratios and figure out. Okay, अगर 2 moles होगा, what would be the charge? 3 moles, what would be the charge, right? Is that clear? So moles of electrons converted into charge or charge converted back into moles of electrons. So it is helpful in that conversion. Okay? You clear? Okay, why you are going to use Faraday constant?
Yes.
There's a Faraday formula, which is that there's a formula for calculating charge. That's a physics formula, current into time. So amperes times second. Okay, that's basically equal to the coulombs, the charge that's flowing. I said so. If there's a charge of if uh, 50 seconds there's a current of 30 amperes flowing, so you would know that it's what's 15 into 30, that's 1500, right? That's the amount of charge that is flowing. If you want to figure out the moles of electrons, then you can use the above ratio to figure out the moles of electrons. Okay? So you clear? So there's this formula Q is equal to IT, जो physics का formula, which is current into time. Are you familiar with this formula?
Yeah.
You clear it?
Yes.
That's
Yes.
Q is equal to IT. So what you're going to do is you're going to use both of these things together. So for example, I've got a question, and the question states, Gibby, there is so there's a current. I mean, there's electrolysis of H2SO4 happens using a current of zero point 0.5 amperes for 2 hours. Now they are asking you to calculate the volume of H2 gas produced. अच्छा, अब इसमें the volume of H2 gas produced. Now For the electrolysis, we know that 2H plus 1 gains 2 electrons and at cathode and it forms. H2SO4 में H plus 1 ions होंगे at cathode, right? It's going to form H2 gas, right? Now, the first thing is I'm going to do Q0 to IT, right? Because current and time both are given. Current is zero point 0.5 and the time is 2 hours. 2 hours is 60 minutes and every minute has 60 seconds. So, Fatma, can you tell me what the answer is? Okay, what is the total charge that's flowing?
3600.
ठीक है, 3600 coulombs. If I have the charge, I can convert that into moles of electrons because I know that 1 mole of electron has Faraday constant. Okay, it's got a charge of 96,500 coulombs, right? So मेरे पास कितना है? That's 3600 coulombs, right? So how many moles of electrons would I have? So if I use ratios to solve,
Be 0.0373.
moles of electrons, right? So now it's pretty easy to solve. Yeah, how many moles of electrons do I have? 0.0373 moles, right? Is that clear?
Yes.
So H2 के moles क्या होंगे? That's going to be half of that. What is half of that?
0.01865.
And volume of gas, let's say it's at RTP to 24 DMQ, and that's going to give you the volume of gas that's produced. So क्या आ रहा है?
0.4476.
0.4476 DMQ, right?
Yes.
So that's your answer. So we clear like coulombs to moles of electrons. You can do that conversion.
Yes.
ठीक है? So for example, अच्छा you try and do this question कि 10 grams of copper is deposited when copper sulfate is electrolyzed for 5 hours. Calculate the current used. So we'll calculate what's the current that's used. I'm going to give you the equation. Okay, copper is getting deposited. तो क्या होगा कि मतलब you can't use Q IT क्योंकि वो आई ही नहीं है आपके पास, ठीक है?
We'll use mole is equals to mass over MR.
ठीक है, तो इसके मोल से निकालो 10 grams है ना. So how many moles of copper do you have?
What's the MR of Cu? It's 63 point something.
0.5.
0.5. Okay. 0.1574. 1575.
0.1575 moles. So what is the next thing that you're going to do?
We will find the moles of electrons, so ratio. So
Okay.
it's 2 times this. It's 0.314. Sorry, 0.315.
Acha, you've got the mole of electrons now. What do you do?
We have to find the current, so we'll multiply. Wait.
मैंने कहा moles of electrons अगर आ जाए, what can you do with that? What was Faraday constant used for?
All right. There was 1 mole of electron is 9625.
96500.
96500.
So कितने moles? That's 0.315, right?
It's 30397.5.
303
97.5.
coulombs, right?
Yes.
So you have the charge now. What is the last thing you're going to do?
We're gonna uh, we're gonna divide this by time, which is 5 hours.
Okay, Q is equal to IT, so
Divide this will be 5 times 60 times 60. So it is
30397
1.69 ampere. Yeah, the current.
times 60. Okay, that's 1 point
1.69.
amperes, right?
Yes.
ठीक है, clear? So, but
Yes.
remember, it's the Faraday constant specifically used for it's specifically used for this part. Okay, this switching between moles and coulombs. Okay, so that is specifically used for that. So that was probably the last thing. There's one more thing which is related to Gibbs free energy, which we did earlier, the feasibility of reaction, right? And I say it's related to. I mean, there's this equation. There's nothing to understand basically. It's just that we did Gibbs free energy early on, which is कि वो क्या था? It was delta G is equal to what? Delta H minus T delta S, right? We talked about reactions being feasible and not feasible, right?
Yes.
Whenever delta G was less than zero, the reaction was feasible. So there's an equation which is linked with delta G, and that's minus n if E naught cell. Okay, we had a lot of E naught cells. Okay, E naught cell is literally uh, the E naught value. N is the number of electrons that are involved in the reaction. F is obviously the Faraday constant. And E cell is E cell, right? So if you this kind of all you have to know is कि एक से होल्ड करते था
जी.
फातिमा, can you hear me?
Yes.
अच्छा अब तो बस ये है कि there's nothing to it, ठीक है, except for कि you have I mean you can calculate Gibbs free energy this way, ठीक है. अच्छा उसके अलावा ये कि there is वो एक दफा चेक कर लेते हैं कि एक दफा चेक करें कुछ चीज मिस हुई, and then we can start doing a worksheet of अच्छा वो सारा हो गया था feasibility done. अच्छा one thing that we are probably going to do is the last में एक चीज रह गई, which is uh, once again salt bridges, standardized electrodes definition, notation भी होगी है, predicting spontaneity and अच्छा shifting equilibrium. We did shifting equilibrium, right? वो क्या था ना
Yes.
कि equilibrium वो के ज्यादा electrons produce करना शुरू करते हैं, that means it's going to become more negative, right? And if it
Yeah.
produces fewer electrons though, uh, तो वो less negative हो जाएगा, ठीक है. अच्छा and then you have nurse equation तो नहीं है, नहीं. I said the only last thing is the hydrogen oxygen fuel cell. वो कर लेते हैं. That's वो ये ओडोज में भी होता था हाइड्रोजन ऑक्सीजन फ्यूल सेल. ठीक है. So you have. अच्छा इसमें क्या होता था हाइड्रोजन ऑक्सीजन फ्यूल सेल में कि you had uh, acidic. I mean, there's basically two electrodes. And so you have two gas electrodes. Or sorry. I said two gas electrodes, and they were platinum electrodes in both of them. ये आपका this is your. एक second. ये जल्दी से बना दें कि this is. के बाकी डायग्राम तो वही है exactly. It's a cell and it will be. अच्छा alkaline भी हो सकता है. It could be acidic as well. You have gas coming in. This is your hydrogen gas, and this over here is your वो oxygen gas. ठीक है. It's a hydrogen oxygen fuel cell. पता आवाज आ रही है आपको?
Yes.
अच्छा, so you've got these gases coming in. So hydrogen gas coming from one side, oxygen gas coming from the other side. अच्छा, solution में you can have an acid in the solution, तो वो water भी होगा. The some of the water might ionize as well, but this is an acidic electrolyte. So if you have the data book here, you can look for equations. जहाँ पे ना oxygen. The data booklet अगर है ना, like if I open the data booklet, so remember it's in ये data booklet खोलो. अच्छा, so oxygen ये जो H plus one वाला नहीं है, the one that's right in front of us, 4H plus 1 plus 4 electron and 2H2, right? इसकी value क्या है? That's 1.23 volts. So यहाँ पे I'm writing the reaction. It's oxygen plus 4H plus 1 plus 4 electrons, and that was in equilibrium with I think 2H2O, and the value was 1.23 volts. I think. I said the other one is it's just 2H plus 1 plus 2 electron in equilibrium with H2 gas, right? Is 0.00 volts. Now, this is the higher potential, so it gains electrons. This is going to go forward, and that's the lower potential that loses electrons. You clear?
Yes.
So 1.23 volts, and this is 0 point. And the electrons are going to move towards the more positive. Okay? So all the electrons will travel. So electricity is going to be produced. Okay? Or you can add up the reactants and the add condition, you would have to multiply this by 2. So if I add up the reactants, it's O2 plus 4H plus 1. Or वहाँ से it's 2H2, that's the reactant, and the product in both cases is 2H2O, and over here it's 4H plus 1, right? The electrons are going to get cancelled out anyways. Or plus ये 4H plus 1 भी cancel out हो जाएगा, so it's just going to be O2 plus 2H2, and you will get 2H2O. Is this clear?
Yes.
So the same exact hydrogen oxygen fuel cell can be used in alkaline medium. Alkaline medium, and your equations would be different if that is still open. तो उसमें सिर्फ जो होगा ना वो इक्वेशन डिफरेंट होगी वो जो ऑक्सीजन और हाइड्रोजन की इक्वेशन होगी ना you will वो OH ions के साथ होगी if you can find like if I try to find equations so I have an equation of oxygen with OH ions, right? ये clear? और
Yes.
hydrogen gas की भी ना I have to look for an equation with uh, उसमें भी OH ion आना चाहिए क्योंकि alkaline medium है ना so यहाँ पे ना if we can वो ऊपर है वैसे I have an equation of hydrogen with OH ions. ठीक है so one value is what -0.83 volts. ठीक है so this is ये मेरे ख्याल से lower है. So this is the one that's going to lose electrons. Hydrogen is the one that's going to lose electrons. और वो जो दूसरी value that's the higher one, so that's the one that's going to oxygen वाली, that's the one that's going to gain electron. The only difference is कि मैंने it's alkaline, so I just वो जो oxygen और hydrogen वाली equation है ना I've just use the ones where OH ions are present. ठीक है ये clear है?
Yes.
तो ठीक है अच्छा next इसके pros and cons of the fuel cell, right? It's all level stuff. ठीक है what were the pros and cons? It's water is the only byproduct, so it's pollution free, right? Water produced, right? Or they're very efficient as well because there's hardly any wastage. I said the negative part is that it's difficult. One of the gases are highly flammable. H2 is very flammable. I said it's very flammable and difficult to store. Storage problems or the storage issues. क्योंकि gas है, it's hard to difficult to store gas under high pressure. तो ये सारे ये clear? बहुत में clear?
Yes.
तो लास्ट वाली जो चीज़ है तो वो तो बस हम कंप्लीट करें फैराडे कांस्टेंट एंड द रेस्ट इसमें हम अब कर लेते हैं कि you can open an edX A2 electrochemistry. easier from Ericsson specific. So मैं एक और सेंड करूँ. So ये वाला starting with the first question. ठीक है, which is on the screen. We कह रहे हैं कि the overall, this is the overall reaction for photosynthesis. Overall means कि this is uh, the reduction plus the oxidation. Is this clear?
Yes.
अच्छा, यहाँ पे वो कह रहे हैं कि water is oxidized in the process, right? So and the half equation. So he has just given us the oxidation equation. और वो कह रहे हैं कि use these equations to deduce the half equation for the reduction of carbon dioxide. ठीक है? तो the issue is क्या कि वो क्या करेंगे कि this is your overall equation. तो उसमें से क्या करना है? You're going to subtract the oxidation equation. Is that clear? तो अगर oxidation equation
Yes.
overall में से निकल आएगी तो you'll be left with the reduction equation, right? So that is what you're going to do. Is this clear?
Yes.
अच्छा, लेकिन होता है कि these equations are always multiplied by a certain number. मतलब कोई x y बीच में multiply हो रहा होता है ना, balancing the number of electrons, right? तो since water is getting oxidized and oxygen is getting produced, तो यहाँ पे overall equation में कितने O2 produce हुए हैं? 6, right? तो इस वाले को ना I'm going to multiply it by 6. वो बात क्लियर है कि क्यों मल्टीप्लाई कर रहे हैं, क्योंकि जब आप दो इक्वेशंस को ऐड करते थे ना, यू वुड ऑलवेज बैलेंस द नंबर ऑफ इलेक्ट्रॉन्स. तो अगर फाइनल इक्वेशन में O2 6 आ रहा है ना, so that means before adding the equations the bottom equation was probably multiplied by 6. That's why you're getting 6 O2, right? Is this clear?
Yes.
अच्छा, तो अब लेफ्ट साइड और राइट साइड को सब्ट्रैक्ट कर लो, so it's going to be 6 CO2 और 6 H2O minus 12 H2O, so that would lead to minus 6 H2O. और फिर राइट साइड पे क्या होगा? That's going to be glucose C6H12O6. O2s cancel out हो जाएंगे, and then it's going to be minus 24 H plus 1 and minus 24 electrons, right?
Wait, sorry. Why is it 2 4 H plus
Hmm?
the the oxidation equation, you are 2,4H plus.
उसको मैंने 6 से मल्टीप्लाई कर दिया था ना,
Oh, okay.
तो 4 की वजह 24 नाउ, राइट? अच्छा, तो इसको
Okay.
रीअरेंज दिस 6 CO2 नेगेटिव वालों को इधर, so it's minus 24H plus 1 plus 24. ठीक है, ये clear है?
Yes.
So that's your leftover reduction equation, ठीक है? जैसा फॉर एग्जांपल अगर मैं वो लिखता हूँ ना, CNA plus AlC plus and 3Na plus 1, and तो मुझे पता है कि Al is the one that's getting reduced, right? Okay, N is the one that's getting oxidized, right? So 3Na plus 1 plus 3 electrons, right? तो लेकिन मतलब अगर मैं वो 3 हटा देता हूँ, that 3 was there to balance out the number of electrons gained and lost, right? तो issue is कि वो overall equation देख के ना पता लग जाता है कि this is getting multiplied by 3, and then you're going to subtract. So when you subtract, so this gets cancelled out, this gets cancelled out. The equation क्या रह जाएगी? It's going to be Al3 plus and arrow and Al plus 3 electrons, right? So you will be left with uh, बल्कि -3 electrons होगा क्योंकि minus कर रहे हैं. So this entire thing is getting subtracted from the above equation. ये clear है? पता?
Yes.
अच्छा, then you have E naught half equation 1 understand include तो वो कह रहा है कि कोई इलेक्ट्रोड है, ये O2 वाला, मतलब ये वाला, वो कह रहा है इसके इलेक्ट्रोड को बनाओ. So this electrode is oxygen and an acid, and तो किस तरह का होगा? It's going to be मतलब gas जब भी होती है, it's a gas electrode, right? So fully labeled diagram that should be used to measure the standard electrode potential of half equation 1, right? So obviously there's going to be a gas electrode, right? अच्छा, so और उसके बीच में there's going to be a platinum electrode, right? So label this that this is platinum. This is where the oxygen gas is coming in, and the oxygen gas is going to be at 1 atmosphere pressure. अच्छा, बाकी the rest is they would all everything would be part of the solution. ठीक है, तो वो अच्छा, so everything is part of the solution. अब solution में क्या होगा? There's going to be H plus ions, aqueous, right? पानी लिखने की जरूरत नहीं है because it's already understood, and these ions would be 1 mole per dm cube, right? So is this clear कि that's how इसको label कर लो? This is going to be your platinum electrode. ये clear है?
Yes. Yes.
अच्छा, और फिर और उसे measure करो. So you always measure it against what? Against a standard hydrogen electrode. उसे how would you measure the potential, right? तो इसी को copy करो, the hydrogen electrode वो paste कर दो इधर. अच्छा, hydrogen electrode में the only difference would be maybe this would be hydrogen, right?
We'll add a salt bridge or
हाँ, बीच में salt base डालना पड़ेगा.
okay.
तो ये वोल्ट मीटर होगा, that's और फिर बीच में इसमें दिया सॉल्ट बेस. ठीक है, ये क्लियर?
Yes.
तो ठीक है, फादर ट्राई इसके क्वेश्चंस ट्राई करो आप. ठीक है,
Okay.
और ये फिर हम ना नेक्स्ट क्लास में करते हैं. ठीक है,
Okay.
ओके.
Nice.